Dear students, in the previous lecture we discussed the equivalent circuit of two-port networks in terms of different network parameters. In this lecture we are going to discuss the concept of reciprocity and symmetricity. So let's start from the condition of reciprocity. Let us see what is the condition of reciprocity. The theorem of reciprocity tells the ratio of excitation to response is constant to the interchange of position of excitation and response. That means even when we are interchanging the position of input and output, the ratio of output to the input to the output is always constant. So let us take the example. See in the figure A. In the figure A we have a two-port network, and at the input port we have connected a DC voltage supply of value Vs volt, and the output port is shorted and we are getting the output current I20 like that. It is flowing in the secondary terminal. So, and in the case of, again let us see the figure 2. In the figure 2 we have connected the same excitation Vs across the secondary terminal, and we see the current flowing to the input port is I10, that is the input port is shorted. So according to reciprocity theorem, the ratio of excitation to response will be constant with respect to interchange of position. Here the position of excitation as well as response has been exchanged in these two figures, and we see the ratio Vs divided by I20, it should be equal to Vs divided by I10. That means I20 should be equal to I10. This is the condition of reciprocity. So let's start the reciprocity condition in terms of Z parameters. That means we'll study the reciprocity conditions in terms of different network parameters. So let us start with Z parameters. So what are the steps to find the reciprocity conditions? The first step we'll write the equations in terms of Z parameters. That is V1 equal to Z11 into I1 plus Z12 into I2. Similarly, V2 will be equal to Z21 into I1 plus Z22 into I2. Now from figure 1, in the case of figure 1, we applied the input voltage Vs, that means V1 is equal to Vs. We sorted the output terminal, that means V2 is equal to 0, and we see the output current is I20, hence we can write I2 is equal to minus I20. So there are three conditions: V1 equal to Vs, V2 equal to 0, and I2 equal to minus I20. So we'll put these three conditions in the first two equations. That means we'll put V1 equal to Vs, V2 equal to 0, and I2 equal to minus I20 in the equations 1 and 2. So we get, from equation 1 we get Vs equal to Z11 into I1 minus Z12 into I20, and from second equation we get 0 equal to, that means the value of V2 is 0, so 0 equal to Z21 into I1 minus Z22 into I20. From these two equations we get the value of I20 is coming Vs into Z21 divided by Z11 into Z22 minus Z21 into Z22. So this is equation A. Next, we see the figure 2. So we'll put the conditions of figure 2 in the equations. The figure 2 conditions are, we see V2 is equal to Vs and I1 is equal to minus I10 and V1 equal to 0. So let us put this condition. We get the equations 0 equal to minus Z11 into I1 plus Z12 into I2. Similarly, we get Vs equal to minus Z21 into I10 plus Z22 into I2. So from here we get I10 equal to Vs into Z12 divided by Z11 into Z22 minus Z21 into Z22. So we know the condition of reciprocity is I1 not is equal to I20. So from equations 1 and A and B we get Z11 that is Z12 equal to Z21. So this is the condition of reciprocity in the terms of Z parameters. That means Z12 should be equal to Z21. If somebody is saying the network is reciprocal, it means the value of Z12 should be equal to Z21. Next is the reciprocity condition in terms of Y parameters. So we write the equation of Y parameters. I1 equal to Y11 into V1 plus Y12 into V2. Similarly, I2 equal to Y21 into V1 plus Y22 into V2. Again we put the condition of figure A, that is V1 equal to Vs, V2 equal to 0 and I2 equal to minus I2 naught, and the condition of figure B is V2 equal to Vs, V1 equal to 0 and I1 equal to minus I naught. So by putting these conditions we get I2 naught is equal to minus Y21 into Vs. Similarly, I1 naught is equal to minus Y12 into Vs. So if we make I1 naught equal to I2 naught, from here we get Y12 is equal to Y21. That is the condition of reciprocity in terms of Y parameter. Next is condition of reciprocity in terms of ABCD parameter. So in the case of ABCD parameter, again we write the two equations, that is V1 equal to AV2 minus BI2 and I1 equal to CV2 minus DI2. So we see, again we put the conditions of figure A and B in these two equations. From here we get I2 naught equal to Vs divided by B and I1 naught equal to Vs into AD minus BC divided by B. So for being the reciprocal, I1 naught should be equal to I2 naught. From here we get AD minus BC equal to 1. So this is the condition of reciprocity in the case of ABCD parameters or transmission parameters, that is AD minus BC should be equal to 1, or we can simply say the determinant of ABCD matrix should be equal to 1. Next is the reciprocity condition in terms of inverse transmission parameters, that is A dash, B dash, C dash, D dash parameters. So when we calculate, we will get again A dash, D dash minus B dash, C dash equal to 1, or determinant of inverse transmission parameter will be equal to 1. Next, the condition of reciprocity in terms of hybrid parameters. So first we will write the equation of hybrid parameters. V1 is equal to H11 into I1 plus H12 into V2. Similarly, I2 will be equal to H21 into I1 plus H22 into V2. So after putting these conditions, we get H12 equal to minus H21. So this is the condition of reciprocity for hybrid parameters, that is H12 should be equal to minus H21. Similarly, when we find the reciprocity in terms of G parameters, we get G12 equal to minus G21. So let us summarize the reciprocity conditions in terms of all the parameters. We see for Z parameters and Y parameters, Z12 should be equal to Z21 and ZY12 should be equal to Y21. Next, for ABCD and inverse ABCD parameters, the determinant should be equal to 1, and for the case of hybrid and G parameters, H12 should be equal to minus H21 and G12 should be equal to minus G21. Next is the condition of symmetry. We have completed the condition of reciprocity. Next is the conditions for symmetry. So we see that if the ports can be interchanged without changing the port voltages and port currents, then networks are said to be symmetrical. That means when we interchange the port, suppose we have applied a voltage Vs and current I1 at the input port and output port is open circuited. Now when we interchange the position, again we get the same values, that is that means the networks are not changing, the conditions are not changing with interchange in the terminals of the ports of the network. So this is the condition of symmetry. So from figure A, we see V1 is equal to Vs and I2 equal to 0. Similarly, from figure B, we see the Vs voltage is connected at the output terminal and input terminal is open circuited. So we see V2 equal to Vs and I1 equal to 0. So for symmetrical network, the ratio should be constant. That means Vs by V1 at I2 equal to 0 should be equal to Vs by I2 at I1 equal to 0. So we have to find the symmetry conditions in terms of Z parameters. So let's start from Z parameters. So we'll put the conditions, that is V1 equal to Vs, I2 equal to 0. Similarly, we'll put the conditions V2 equal to Vs and I1 equal to 0 in the equations of Z parameters. From here we get V1 equal to Z11 into I1 plus Z12 into I2. So we write Vs, instead of V1 we'll write Vs. So Vs will be equal to Z11 into I1 plus Z12 into, the value of I2 is 0, so here it will be 0. From here we get Vs by I1 at I2 equal to 0 is equal to Z11. Next we'll put the conditions of figure B in the equation. So by putting the conditions of figure B, we get V2 equal to Z21 into I1 plus Z22 into I2. So in this equation we'll write V2 equal to Vs and I1 equal to 0. So from here we get Vs equal to 0 plus Z22 into I2. From here we get Vs by I2 at I1 equal to 0 is equal to Z22. So when we from the condition of symmetricity, these two ratios should be equal. It means Z11 should be equal to Z22. In terms of Z parameter, the condition of symmetry is Z11 should be equal to Z22, where we saw that the condition of reciprocity, Z12 should be equal to Z21. Next we have to calculate in terms of Y parameters. So again we will put the conditions of figure A and figure B, that is V1 equal to Vs and I2 equal to 0 from figure A in the equations I1 equal to Y11 into V1 plus Y12 into V2 and I2 equal to Y21 into V1 plus Y22 into V2. So from here we get we'll get I1 equal to Y11 into Vs plus Y12 into V2. Similarly, 0 will be equal to Y21 into Vs plus Y22 into V2. From here we get V2 equal to minus Y21 divided by Y22 into Vs. That means the putting in equation A. Now from here when we put the value of V2 in the equation A, that means I1 equal to Y11 into Vs plus Y12 into V2. When we put in the equation A, we get I1 equal to Y11 into Vs minus Y12 into Y21 divided by Y22 into Vs. From here we get I1 equal to Y11 into Y22 minus Y12 into Y21 divided by Y22 Vs. From here we get Vs divided by I1 equal to Y22 divided by del Y. Del Y is nothing but Y11 into Y22 minus Y21 into Y12. Similarly, we'll put the conditions of figure B, that is V2 equal to Vs and I1 equal to 0 in the equations of Y parameters. From here we'll get Vs divided by I2 at I1 equal to 0, it will be equal to Y11 divided by del Y. That means for the symmetrical network the condition is Y11 should be equal to Y22 in terms of Y parameters. In the case of reciprocal network, we saw the condition was Y12 should be equal to Y21. Now in terms of transmission parameters, we have to find the condition of reciprocity. The first step is we'll write the equations of transmission parameters. V1 equal to A into V2 minus B into I2. Similarly, I1 equal to C into V2 minus D into I2. Next step is we'll put the conditions. We have to put the conditions of figure A and B in the equations. After putting the conditions, we get Vs equal to A V2 and I1 equal to CV2. That means here we have made I2 equal to 0. From here we get Vs by I1 at I2 equal to 0 is equal to A divided by C. Similarly, by putting the conditions of figure B, that is V2 equal to Vs and I1 equal to 0, we get Vs by I2 equal to at I1 equal to 0, it is equal to D by C. So after equating these two terms, these two equations, we get the condition of symmetry, conditions for symmetricity in the case of, in terms of ABCD parameter is A equal to D, where the reciprocity condition was determinant of ABCD is equal to 1, that is AD minus BC was equal to 1. Next, again when we calculate in terms of inverse transmission parameters, again we will get A dash equal to B dash, D dash, that will be the condition of symmetricity. Next, in terms of hybrid parameters, again we will put the conditions of figure A and figure B in the equations of hybrid parameters. We will get Vs equal to H11 into I1 plus H12 into V2. So here we will make, and second equation will be 0 equal to H21 into I1 plus H22 into V2. So from here we find Vs divided by I1 at I2 equal to 0 is equal to del H divided by H22. Next we have to put the conditions of figure 2, that is V2 equal to Vs and I1 equal to 0 in the equations. We will get V1 equal to H12 into Vs plus and I2 equal to H22 into Vs. So from here we get Vs divided by I2 is equal to 1 divided by H22. So when we compare these two terms, these two equations, we get H22 at the denominator sides common, so it will be cancelled out. So the condition for symmetricity will be del H equal to 1. So the meaning of del H equal to 1 is H11 into H22 minus H21 into H22 equal to 1. Again when we calculate for G parameters, we will get the same condition, that is del G equal to 1. But in the case of condition of reciprocity, you saw that H12 was equal to minus H21 and G12 is equal to minus G21. Now let us summarize the conditions of reciprocity and conditions of symmetricity for all the parameters in terms of all the parameters together. So we have put three columns. First column is telling the parameters, second column is representing the conditions for reciprocity, third column is for conditions of symmetry. So let us see in terms of Z parameters. For reciprocal network, Z12 should be equal to Z21, and for symmetric network, Z11 should be equal to Z22. Similarly for Y parameter, for reciprocal network, Y12 should be equal to Y21 and Y11 should be equal to Y22. Similarly for ABCD parameter, AD minus BC should be 1 for reciprocal network and A equal to D should be equal to D for symmetric network. Next for A dash, B dash, C dash, D dash parameters, the determinant of A dash, B dash, C dash, D dash, the matrix should be equal to 1, and for the condition of reciprocity, and for condition of symmetricity, A dash should be equal to D dash. Next for H parameter, that is hybrid parameter, the condition of reciprocity is H12 should be equal to minus H21, whereas the condition of symmetry is del S should be equal to 1. Next for G parameters, the condition of reciprocity is G12 should be equal to minus G21 and condition of symmetricity is del G equal to 1. So we saw that we have three pairs of parameters, that means J and Y are inverse of each other, transmission and inverse transmission parameters are inverse, and H and G parameters are inverse. So Z and Y parameter, the condition is similar. For ABCD and inverse ABCD, the condition is similar, and for G and H, the condition is similar. So by this way we have to remember all the conditions for symmetry and network and reciprocity.